What was NASA's Gemini program? In today's video we embark on an in-depth journey through NASA's historic Gemini missions, a pivotal chapter in the conquest of the cosmos. The genesis of NASA's Gemini program can be attributed to the geopolitical tensions of the early 1960s, particularly the Cold War rivalry between the United States and the Soviet Union. In this charged atmosphere, NASA recognized the need to accelerate its space exploration efforts, especially in the context of the moon race. Consequently, the Gemini program was born as a strategic initiative to bridge the gap between the Mercury and Apollo programs. Its primary objective was to develop and test critical spaceflight techniques such as rendezvous and docking, spacewalking, and prolonged missions that would be essential for the upcoming lunar missions. This visionary program laid the foundation for the historic moon landings of the Apollo program. NASA carefully selected a group of elite astronauts, the new 9, to undertake these critical missions. These astronauts underwent rigorous training, pushing the boundaries of human endurance. The NASA Gemini spacecraft was a technological marvel of its time, designed and built to serve as a vital stepping stone for lunar exploration. This two-person spacecraft featured a host of groundbreaking innovations, including an onboard computer, precision thrusters, and a rendezvous and docking system. It was instrumental in perfecting critical techniques required for lunar missions, such as orbital rendezvous and docking. Additionally, the Gemini spacecraft played a pivotal role in advancing extravehicular activities, which is spacewalks, setting the stage for NASA's future lunar expeditions during the Apollo program. On March 23, 1965, Gemini 3 became the program's inaugural mission. Astronauts Gus Grissom and John Young orbited the Earth 3 times, demonstrating the spacecraft's capabilities and conducting experiments. Gemini 4, commanded by James McDivitt and piloted by Ed White, holds a significant place in space history as a pioneering mission for several reasons. First and foremost, it marked the first American spacewalk as Ed White ventured out the spacecraft for a historic 23-minute spacewalk tethered to the spacecraft by an umbilical cord. This extravehicular activity, EVA, was a critical milestone demonstrating the feasibility of astronauts working in the vacuum of space. It also laid the groundwork for future spacewalks, which were vital for repairing spacecraft, conducting experiments, and ultimately lunar surface operations during the Apollo missions. Furthermore, Gemini 4 showcased the spacecraft's endurance, lasting 4 days and orbiting the Earth 66 times. This extended mission duration provided valuable insights into the physical and psychological challenges of long-duration spaceflight, essential for planning longer missions to the moon. In summary, Gemini 4's spacewalk and mission duration significantly contributed to NASA's growing expertise in human spaceflight and paved the way for ambitious lunar exploration. The Gemini 6 and 7 missions were pivotal in advancing the crucial technique of rendezvous and docking in space, a skill essential for future lunar missions. On December 15, 1965, Gemini 6, piloted by Walter Schirra and Thomas Stafford, executed the first ever rendezvous in space. It achieved a historic feat by closing in on Gemini 7, already in orbit, to within just inches, showcasing the precision required for spacecraft to meet in space. This achievement was instrumental in proving that astronauts could maneuver their spacecraft to dock with another vehicle while orbiting Earth. It laid the foundation for lunar module docking during the Apollo missions, where the command module would rendezvous with the lunar module in lunar orbit. The success of Gemini 6 and 7's rendezvous and docking maneuvers marked a significant leap forward in NASA's quest to land humans on the moon. Gemini 7, commanded by Frank Borman and piloted by Jim Lovell, achieved historic significance as the longest manned mission at that time. Launched on December 4th, 1965, it remained in space for nearly 2 weeks, a remarkable feat that pushed the boundaries of human endurance in the early days of space exploration. The mission's primary goal was to study the physiological and psychological effects of prolonged spaceflight on astronauts. This data was invaluable for NASA's planning of future missions, particularly the Apollo program, which aimed to send humans to the moon and required astronauts to endure long-duration missions. Gemini 7's success demonstrated that astronauts could withstand extended periods in space, providing the confidence and knowledge needed to tackle the challenges of lunar missions. It played a crucial role in paving the way for NASA's historic moon landings, marking a significant milestone in the journey to conquer the cosmos. Gemini 8, piloted by Neil Armstrong and David Scott, faced a harrowing ordeal during its mission. On March 16, 1966, the spacecraft successfully docked with an Gemini target vehicle in orbit, a critical test of rendezvous and docking techniques. However, shortly after docking, the mission took a dangerous turn as the combined spacecraft began to spin uncontrollably. Neil Armstrong's quick thinking and precise actions were instrumental in averting a potential disaster. He undocked the Gemini from the Agena, which had suffered a thruster malfunction, causing the spin. Despite the life-threatening situation, Armstrong's skills and composure allowed them to stabilize the spacecraft, ultimately saving the mission and their lives. Gemini 8's harrowing ordeal underscored the risks and challenges of space exploration and demonstrated the importance of astronaut training and problem-solving skills. This mission also provided valuable lessons that contributed to the success and safety of subsequent space missions, including the Apollo program. Gemini 12, the final mission of NASA's Gemini program, marked a grand finale filled with significant achievements. Commanded by Buzz Aldrin, piloted by Jim Lovell, the mission took place from November 11th to 15th, 1966. It was a testament to the program's success as Aldrin conducted 3 successful spacewalks, setting new standards for extravehicular activities and demonstrating that astronauts could perform complex tasks in the vacuum of space. The mission also included successful rendezvous and docking with an Agena target vehicle, further refining the critical skills necessary for lunar module docking during the upcoming Apollo missions. Gemini 12's accomplishments, especially in the realm of EVAs, were instrumental in shaping the training and procedures for the lunar surface activities of the Apollo program, making it a fitting and triumphant conclusion to the Gemini program. The Gemini program's legacy is immeasurable. It provided NASA with the knowledge and confidence needed to take humanity to the moon. Its success and challenges forged the path to Apollo, forever altering our relationship with the cosmos. Join us next time as we continue to explore the fascinating history of space exploration. Don't forget to like, share and subscribe for more captivating content here on ONE.Aerospace.